Automatic. Addison.
In this tutorial, we will explore multithreading and time functions in C++. Let's explore how to implement threads in C++ for robotics projects. Threads allow multiple tasks to run simultaneously, which is essential for parallel processing in robotics applications. I have Visual Studio open, and let's create a new file called threads.cpp. Okay, and let's write the code here. So pound include IOStream. Pound include thread. Pound include chrono. Okay, and let's do void. And I'm going to use camel case this time so you get some experience with that. Sensor task. Let's do const stood string sensor name, and then do int, and let's do what should we do here? Let's do duration. Okay, so we have our first method, sensor task, that we have defined, and now let's fill it in. So I'm going to do stood cout sensor task started. Do sensor name. Okay, and let's do stood indel. And now let's do stood. I'll explain what all this is in a bit. So this thread, sleep for stood, chrono, seconds, duration. Okay, and let's close that out. And now let's do stood cout sensor task completed, sensor name. Okay, and let's close that out with a stood indel. Okay, looking good, looking good, looking good. And let's write another one. We'll do void. Let's just copy all of this gobbledygook. So we're going to reuse that, and let's do control task stood string controller name. And duration. Let's do control task started. Let's do controller name. Okay, and duration. All right, and then control task completed. And then controller name again. Now let's do our main function, int main stood cout main thread started stood indel. And let's create threads for sensor tasks. So we're going to do stood thread sensor thread 1 sensor task. Okay, and then we'll do temperature sensor comma 2. All right, and we need to repeat that. So these are our threads for our sensor tasks. Okay, and let's do our second one. And we're going to do humidity. Humidity sensor. Do 3. Okay, that's our second. That's our extra other thread. All right, and now let's create a thread for our control task. So stood, thread, control, thread, control task. I do motion. Okay, motion controller, comma 4. Okay, how are we looking so far? That's good. Initiating those threads, and now let's create some code where we wait for the threads to finish. Yeah, we join them right here, sensor thread to.join. Oh, so join. Okay, so when we run this code, this will enable our code to wait for the threads to finish. And then stood cout main thread completed. Stood end L. Okay, and then as always, let's do a return 0. So what are we doing in this code? Let's go through it very slowly. So we define 2 functions, sensor task and control task. Sensor task and control task. These functions simulate tasks performed by sensors and controllers in a robotic system. Each task prints a message when it starts and completes, and sleeps for a specified duration using this thread and sleep for this piece right here. In the main function, we create 3 threads. 2 threads for sensor tasks, sensor thread 1 and sensor thread 2. So these threads execute the sensor task function with different sensor names and durations. And then our other thread right here is the control task. It's called control thread. This thread executes the control task function with the controller name and duration. Now, after creating the threads, we use join. Join right here. And this join right here enables us to wait for each thread to finish before proceeding further in the main thread. All right, now let's right click, run our code. You can see it popping up, main thread completed. And so the output displays the messages from each thread, indicating when they start and complete. And the threads execute concurrently, which means at the same time. And the main thread waits for all the threads to finish before completing. Let's explore how to use time functions in C++ to enhance your robotics projects. Time functions are essential for tasks such as measuring elapsed time, creating delays, and synchronizing actions in robotic systems. We will use the Chrono library, which provides a set of convenient functions to work with time in C++. Let's create a new C++ file and name it timeexample.cpp. And let's type the following into the code editor. #include iostream. And we're going to do #include chrono. And #include thread. Now let's do int main. Let's do auto start time. is equal to stood, chrono, steady clock, now. Okay, let's go down here and let's do stood. This thread, this thread, sleep 4, stood, chrono, seconds 2. It would do auto end time equals stood, chrono, steady clock, now. Do stood, chrono, duration, double, and do elapsed seconds. And we'll do end time minus start time. Let's do stood, see out, elapsed time, elapsed seconds, dot count, seconds. And now we do return 0. Okay, looking good, looking good. In this code, we include the necessary headers, IO stream for input-output operations, chrono for time functions, and thread for creating delays. Then in the main function, we capture the start time using stood, chrono, steady clock, now, stood, chrono, steady clock, now, all right? And then next, we create a 2-second delay using this thread sleep 4 and the 2 seconds. Finally, we capture the end time and calculate the elapsed time by subtracting start time from end time. We then print the elapsed time using stood cout. Let's run the code. And there we go, elapsed time 2.00318. So you should see the elapsed time printed in the terminal. Thank you for watching. I'll see you in the next tutorial. Keep building.